Hi guys, this is the electrolysis required practical for AQA. It is required practical activity number 9 if you are a combined scientist, and required practical activity number 3 if you're doing separate science or triple science. I'm going to take you through the practical, show you how it's done. You need to know how to set it up, how to draw a diagram of it, how to summarize it. Now, if you're a triple scientist or a separate scientist, you also have one bit extra. You have to describe the test for oxygen, hydrogen, and chlorine. So I'll be going through those. If you're a combined scientist, those are at the end of the video, so you can skip that. But I'd advise you to still watch it because you need them for your paper 2 exam. And this is a required practical for chemistry paper 1. So let's get into it. Okay, guys, here's my electrolyte solution, my battery or power supply, which is positive at one end and negative at the other end. So you need to be able to explain how to set these three items up. So we have the electrodes here. These are made of graphite, or you can call it carbon. It's an inert substance, so it won't react with my electrolyte solution. I'm going to connect the positive end of the battery to make a positive electrode, and the negative end of the battery to the other electrode to make a negative electrode. A positive electrode is known as the anode, and the negative electrode is known as the cathode. Here I'm pointing to the positive end of the battery, and that is linked to the anode or positive electrode. Now, I'm going to need to place my electrolyte solution so that it covers the electrodes. You can say place the electrodes in electrolyte or pour electrolyte onto the electrodes, either one, as long as you've mentioned that the electrolyte and the electrodes are together. Now you can see gases coming off at each electrode. I have chlorine gas coming off at the positive electrode and hydrogen at the negative. So another piece of equipment you need to know about is mini test tubes. You can just say test tubes and you place them over the top and you can collect the gas. If you need to measure the volume, you could use test tubes which have a scale on them. My ones don't. Now, if you're doing triple, you need to know how to test for chlorine gas. So here I have damp blue litmus paper. I'm going to slide a bit into one of the test tubes and place this back over the positive electrode where my chloride ions are being discharged and turned into chlorine. I leave this for about a minute. What I should find is that the damp blue litmus paper is going to get bleached because chlorine acts as a bleach. So it's eventually going to turn white. It may turn pink or red first because chlorine is acidic. You can see here it's been bleached. It's lost all of its blue color. And so that is the test for chlorine. Hi guys, so how do we draw a diagram for electrolysis? Well, you've got to start with a battery or power supply. Make sure you label the positive electrode that's connected to the positive part of the battery and the negative electrode connected to the negative part of the battery. You also have to know that it's the positive electrode is called the anode and the negative the cathode. Okay, you need to place the electrodes into the electrolyte and draw that as such. Place test tubes over the top, and these are so you can collect gases. Even better if they have a scale drawn on them, a calibrated scale. But at a push, you could say use a measuring cylinder or a gas syringe to measure the volume of gas that's produced at the electrodes. Now, let's go on to the summary of how we set up the apparatus. Just like in the diagram, connect the battery, power supply with wires and crocodile clips to electrodes. Use inert electrodes made of carbon or graphite. They won't react with the electrolyte. Put the electrolytes in the electrodes, in the electrolyte. Place test tubes that have a measuring scale over the electrodes to collect and measure the volumes of gases. It's also worth noting that the carbon or graphite electrodes conduct electricity because they contain delocalized electrons between the layers in graphite. That's why we choose graphite also as an electrode. So here is the test for chlorine gas. We did this in the video. So place damp blue litmus paper in the tube. It's going to turn red because it's acidic. and then it's going to bleach white, which is the most important point, that the test for chlorine gas will bleach white damp blue litmus paper. You need to know this in paper 2, can come up in your exam, but also if you're a triple scientist, you need to know this for the paper 1 required practical that we've covered today on electrolysis. Okay, let's move on to the next test for gas. So we also have hydrogen gas, which is collected at the cathode. That's because hydrogen ions are cations. They will be discharged at the cathode, which is the negative electrode. So we place a splint, a lit splint, at the opening of the tube, and you'll hear a squeaky pop. Hydrogen's explosive, flammable, one of the downsides to using hydrogen, but that's why we can test for it. We get a little pop. You also need to know how to test for oxygen gas. Now, oxide ions are negative, so negative ions are going to go to the anode, the positive electrode, and we can test for them being discharged into oxygen molecules by placing a recently extinguished or glowing splint in a test tube, and if it relights, oxygen is present. So guys, I hope that's been helpful, and once again, let's get to the marks.